Okay, I'm sorry to the girls soccer team. Sounds like you guys had a great game. There's no shame in losing in the section final. Season's going to end at some point. It's always sad when it does, but sounds like you guys gave the Algebraically fans quite a thrill, and I should be very proud to represent the Big Nine Conference in the way that you guys did. So always fun to make it to state, but sometimes it doesn't work. True team girls swimming, 7th in the state. That's awesome. That's very exciting. It's a great finish. We have the same thing track and field for True Team. I would love to make a True Team state sometime. We did when I was in high school. With my team, we made it a few times, and that was great. But very exciting process to go through. Volleyball plays Friday night at home. Hosting a section match. 4th seed out of 12 or so. Congratulations to you. Cross country has sections Thursday at Owatonna. Okay, I'm going to try to go to that. And anything else going on? Am I missing anybody? The hockey jackets are being worn today. If you guys could keep it down today during class, we'd appreciate it. Thanks. All right, here we go. State the domain for the following. Today, our objective is that we would like to algebraically define what the domain is for given functions. And the domain is what we call the inputs, often the x values. Okay? So for your test, you have to memorize the definition of a function. And if you remember, the definition of a function is an equation or a relation in which every element of the domain corresponds to exactly one element of the range. Very good. Question. I will say define what it is to be a function, and you will write it down. Yes. When does the quarter end? Next Friday? I don't know. Usually, I don't get this in before the quarter. However, we've been able to save on a little bit. Again, we're trying to save on time because we want to review for the final exam. A couple other things. So we might get it in, but I don't know. Depends on how long this next section takes. Again, we're skipping a section, and after today, we're done with 2.1. And so we'll see. I'll try to give you an answer tomorrow or Wednesday. So, but that's the definition of a function. And the domain is the inputs, or the x values. And what you need to consider when you're working with domain are things like undefined values and things like roots. So if you look at this example, it says state the domain for the following. And the domain, again, is the available x values that you can plug in. Okay? Now, just to give you an idea, we'll start with a really easy one. Oh, I always do that. Wrong class. Okay. What does the first graph look like? It's a line. Yeah, exactly. It goes through -3. You tell me, are there any numbers that you can't plug in for x? Like, can you plug in 0 and get a result? Can you plug in positives? Can you plug in negatives? Yeah, for this one, we say x is all real numbers. You know, you can plug in everything. So the domain is all reals. You'd say interval notation would be -∞ to +∞. How does it change if we square it? You can still plug in any value, can't you? There's no restriction on it. Again, the domain here, and the domain for basically any polynomial that you see is all real numbers. Okay, you know, so you could have x to the 6th minus 4x to the 5th minus 8x squared plus 2. X minus pi. It doesn't matter really what you have. It's a polynomial. You can plug in whatever you want, and you're going to get outputs. The domain is going to be all real numbers. But if we switch it and we consider things like square roots, well, that kind of changes what we're doing a little bit, okay? Can you take the square root of positive numbers? Can you take the square root of 0? Yep, square root of 0 is 0. Can you take the square root of negatives? No. So what I have to do, and it's different for each one. You really have to understand what you're trying to solve here. We're saying that 9 minus x has to be non-negative. It can't be negative, right? So how would you write that mathematically? Yes. Yep, we'll set that up. 9 minus x is going to have to be greater than or equal to 0. That's what it means to be non-negative. It's got to be positive or 0. Okay? So this part underneath the square root, we only want it to be positive or 0. Well, now we solved that. We subtract 9 from both sides. Get negative x is greater than or equal to negative 9. What happens when I divide by a negative? Switch the sign. So x has to be less or equal to 9. That is my domain. Those are the available x values that you can plug in and get results. If you're curious, try plugging in something. What is the value that satisfies this domain? Give me anyone. 8. 9 minus 8 is? Square root of 1 is? 1. Good, it worked. Give me a value outside of the domain. 10. 9 minus 10 is? Negative 1. Square root of negative 1? It's imaginary. So you can understand why this restriction is so important. It tells you what you can use and what you can't. Now here we don't have a square root, but let's think about the top. If you have a fraction, can the top be equal to a positive? Can the top be 0? Can the top be negative? Yeah, so we don't have to focus on the top at all. It's just the bottom. Can the bottom be positive? Can it be negative? Can it be 0? No. So the bottom cannot be equal to 0. So we solve that like we would anything else. We add 2, we get x cannot be 2. That's my domain. If you wanted to write it in interval notation, for this one you would do negative infinity to positive 9, bracket, just as Scott said. If you want to do this one, you would do negative infinity to 2, and then 2 to infinity. Forgot to include my union. You can see that I've excluded 2 from that value. So that's how we do it. And I would accept either answer. It doesn't really matter to me. As long as you know x can't be 2, that's fine. Any questions on these two? Going once, twice, thrice. Flip it over. Got 4 more here. Okay. So the next one's a fraction. So I have to be concerned about what part of the fraction. The bottom. The bottom cannot be equal to. So I take the bottom and I say it can't be equal to 0. And I try to solve that. How do you solve something like that? Starts with F, rhymes with actor. Factor, yes. Factors 2. Plus 2 minus 3. My solutions are negative 2 and positive 3. So x cannot be equal to negative 2 or 3. Again, if you wanted to express that in interval notation, negative infinity, negative 2, union with negative 2 to positive 3, union with 3 to infinity. If you want to express it in interval notation, that's fine. I don't remember how your book puts it, so. Ooh, let's think about the next one. Can you take the cubed root of a positive? Can you take the cubed root of 0? Can you take the cubed root of a negative? Yeah. Look. What is the cubed root of 27? Whoop. Yeah, it's 3. What is the cubed root of 0? What's the cubed root of negative 8? Negative 2. You can take the cubed root of all numbers. So therefore, what's the domain? All reals. You plug in anything you want. So again, I can't tell you what to do every time. You got to think about the type of function it is and solve it from there. Missing Preston today, huh? It's that day. So much more quiet when he's in here. It's easier to see too. His hair doesn't get in the way. All right, 9 minus x squared. This one's more challenging for people. What to do? What to do? What to do? Very good. Scott's got it. What do I do? What do I do? 9 minus x squared has to be greater than or equal to 0. Okay, if it's an even root, it's got to be positive or 0. If it's an odd root, it can be anything. So this is an even root. If it was 4th root, same thing. 6th root, same thing. 8th root, same thing. If you got an odd root, you can use whatever you want. But we have an even root, so it's got to be greater than or equal to 0. Well, this is quadratic. You can't just solve this by factoring, 3 minus x, 3 plus x, greater than or equal to 0, and then setting both of those greater than or equal to 0. It doesn't work like that. We got two options. We either need to use the box method, or we need to look at the graph. Now, do you know what the graph of 9 minus x squared looks like? What shape does it make? 9 minus x squared makes a parabola. Does it go up or does it go down? It goes down. And I see that the solutions are positive 3, and negative 3. So as I make my little graph for the parabola, negative 3, positive 3, you guys said it goes down, and it passes through those values. I have to answer the question. It says, where is it greater than or equal to 0? Graphically speaking, what does it mean to be greater than or equal to 0? Above the x-axis. Well, you tell me. Right here is the graph above or below? Below, so it's negative right here. Right here is the graph above or below? Positive and negative. So you're looking for the portion that is above the x-axis. You can see that that happens when x is between those numbers. Or, express it in interval notation, negative 3, positive 3. How do I know I can include this negative 3 and positive 3? Yeah, when you plug these back in, you get 0, and it's okay to take the square root of 0, so you can include those. Any questions on that one? All right, we just got one more. Oh boy. Now I got both, don't I? Now I've got a square root, and I've got a fraction. Square root and a fraction. What do we know about the square root? The inside has to be positive or 0. So greater than or equal to 0. I'm done with the top part. What is the problem with the bottom? The bottom can't be, so I say x squared minus x cannot be 0. Take out an x. What are my solutions? 0 and 1. Now, let's think about this, you guys. On the top, I have this restriction. I have to be greater than or equal to 0. On the bottom, it says I can't be 0 or 1. Are those two in conflict with each other? They sure are. Yeah. In fact, question, no. If you were to graph this, x greater than or equal to 0, it will look like that, right? But what two values do you have to exclude? 0 and 1. How do I exclude 0? Open circle. How do you exclude 1? Open circle. So, that's how it would look like as a graph. But if you wanted to, write it in interval notation, you can include 0 and you can't include 1. And then we go from 1 all the way to infinity. And so you have to reconcile them between each other. You've got to consider both cases and look at their overlap. If you just let it greater than or equal to 0, you got a problem because 1 and 0 don't work. If you only choose 1 and 0, well, then you forget about the negatives as well. So you gotta make it work between both. Okay? What do you think? Easy? Hard? You're like, yay, Mr. Gintz, please give me more. I would like more examples to go over. Say, no, give me an assignment. I'm ready to work. Okay, we'll do that. Okay, so on Friday, I gave you the bottom part, which is right up here. Today, I give you 47 through 54, 57, 58, 60, which will end section 2.1. It's also right here on the board. I forgot to run off packets, so you guys wouldn't have to bring your books. I could try to do that right now if you want. I'll try to go do that. If you guys give me a few minutes, will you give me a few minutes? Nope, Taylor's not going to. Yes. That's fine. Yeah, or if you have a phone, you want to take a picture of it quick so you can use it that way, that's fine. And then, if you want the recipe for my chocolate chip cookie bars, chocolate chip cookie bars, now it's on YouTube for the whole world to see. What did I have from last week? The video? I don't think I put Fridays up. Actually, I don't remember. Wednesday, thank you. We're going to have school on Friday. Krista D, what do you want? Oh, the recipe? Some people took a picture of the recipe. That would be fine as well. Let me go to Zoom, and we'll just do 100%. And let me stop the video first. Goodbye, YouTube Nation.